Here's sample test problem number 2. In block M1 is released from rest from A and slides on a curved frictionless track until it collides elastically with block M2, also initially at rest. The masses of M1 and M2 are 5 kilograms and 10 kilograms respectively. Calculate the maximum height to which M1 rises after the collision. This is really 3 problems in one. We're going to have conservation of energy in this first part as mass 1 slides down to hit mass 2, and then we're going to have an elastic collision. Let's make note of that, and momentum and kinetic energy will be conserved in that, and then we're going to have another conservation of energy problem as mass 1 rebounds and obtains some kind of final height. So we need to approach these 3 problems separately. First of all, conservation of energy. What is mass 1's initial speed right before it hits mass 2? And that is going to be equal to square root of 2gh. For starting from rest and going down a certain height h, that's 2 times 9.8 times 10 meters, square root of 196, which is 14 meters per second. Sounds good. So then we want to find the final velocity after this elastic collision. So V1 final is going to be equal to M1 minus M2 over M1 plus M2, V1 initial plus 2 M2 over M1 plus M2, V2 initial, for and only for an elastic collision. In this case, V2 initial is 0, and so this is equal to mass 1, which is 5 kilograms, minus mass 2, 10 kilograms, over mass 1 plus mass 2, times V1 initial, which is 14 meters per second. And that's equal to a negative 4.67 meters per second. So after this elastic collision, that is the final velocity of mass 1. That's going to be converted with that kinetic energy, 1/2 mass 1 V1 final squared, into potential energy of mass 1 g final height, let's call it h prime. Mass 1 cancels out, and we have that our final height is equal to our V1 final squared over 2g, which will be a negative 4.67 meters per second squared over 2 times 9.8, and that's equal to 1.11 meters. So the final height that M1 rises to is 1.11 meters. We had to approach it by conservation of energy, conservation of momentum and energy in the elastic collision, and then conservation of energy again. 3 separate problems in one, a bonus problem.